All right, here's an example of one of the online homework problems. This is number 16 from the section 4.1 problems. And the main thing to do here is to first take a second to do a rewrite of each of these terms so that each one looks like a number times the power of x. And once we have the terms written that way, then we can apply our power rule to each one of them. So we'll start with a rewrite, and I'm sorry for the big writing. I'm having trouble with a stylus, so this is writing with my finger as best I can. So the rewrite here, we want everything to look like a power of x. So we see the first thing already is, it's x cubed, so that's fine. This last thing also is already written as a power of x, x to a power, so that's good. This is the only one that has something weird about. It's written with a radical symbol, square root symbol, instead of as a power. But we know that the square root of x is the same as x to the 1/2. So let me just take a second to rewrite this. So I have x cubed minus 9/2 x to the 1/2 plus x to the minus 4/3. So again, I haven't used any calculus yet. I'm just rewriting this so that each term looks like a number times the power of x. And now for each one, I'm going to use the power rule. So here's how I use the power rule. I leave myself a space. So that's my way of saying I'm going to leave a space. And I take my power of x and I raise the power by 1. So x to the 4th. And then I go back and say the number that goes here should be the reciprocal of this number. So if that's the number 4, the reciprocal of that is 1/4. And so antiderivative of x cubed is 1/4 x to the 4th. But notice that I don't do it in that order. I first figure out what the power is because that's as easy as adding 1, and then I write here the reciprocal of that new power. All right, moving on. So I have minus 9/2. And again, now I'm stuck with this power of x. Add 1 to the power. Well, make sure I leave a space, leave a little gap. X raised to the 3/2 power. So adding 1 to the power 1/2 gives me 3/2. So now I have x to the 3/2. The number that goes in front here is the reciprocal of 3/2, so 2/3. And then plus this term, x to the minus 4/3. There's no number in front, so that makes it easy. I now just leave myself a gap. Figure out what my power of x is. My power of x should be 1 more than negative 4/3. So 1 more than negative 4/3 is negative 1/3. And the number that goes in the space that I left, this space right here, is the reciprocal of negative 1/3, which is negative 3. So I could even erase, I guess I can't erase, but negative 3. So negative 3 over 1. So that gives me a little bit of arithmetic to resolve. For example, 9/2 times 2/3, these 2's will cancel, 3 will cancel with the 9. So this 9/2 times 2/3 is just 3. And so I can at least do the arithmetic. There's no real algebra to simplify here, but if I've got two terms multiplied together, I might as well multiply them. So I have 1/4 x to the 4th minus 3x to the 3/2 minus 3x to the minus 1/3 plus any constant. Don't forget that once you have the answer, or oops, have what you think is the answer, you can always check. And I've run out of room here. I can't seem to move the screen down, but I'll just say it. So checking would be taking the derivative of each of these terms, since we are more familiar with the derivative rules, and see if that's not what we started with here. So for example, the derivative of 1/4 x to the 4th is the 4 will come down, hit the 1/4, that's a wash, you have x cubed. So the derivative of 1/4 x to the 4th is in fact x cubed. The derivative of minus 3x to the 3/2 is negative 9/2 x to the 1/2, which is that guy. And the derivative of minus 3x to the minus 1/3 is positive 1 x to the minus 4/3, which is that term. So it's very easy to take each derivative of these terms and match it up and see that that really is correct. So the difficulty of these problems is really just, well, the only difficulty I think that's going to happen is when these terms have lots of weird things like powers of x in the denominator or different kinds of roots, we have to translate those into powers of x. But once we have the problem written as number times power of x, number times power of x, number times power of x, then we just use the power rule over and over again and get the right answer.